you? Let's start with some audience participation. Everyone loves that. So, first things first, who here uses microservices in general in their day-to-day? That's an easy one to get a hand raise. Who has a dedicated orchestrator as part of that microservice architecture? We have 3, 4. Fantastic, because that means the first couple of slides are going to be so boring for most of you. So I'm going to be talking, well, first of all, I'm going to be talking about microservice orchestration very briefly, just discuss it a little bit, explain what it's about, but then talk about the 2 main ways people tend to integrate services when they're using an orchestrator. And that's one that's very pro-code and one that's very low-code. I'll just discuss the benefits of those and when maybe a good time to use them would be in general. So let me turn this on. So this is what I look like very occasionally, maybe a wedding or something. I'm Niall Deehan, I'm a developer advocate with Camunda. Camunda builds orchestrators, so I kind of know about this stuff. And I want to give a little quick history lesson about where we're at. So we are the bird there. And basically speaking, when microservices showed up, of course, they needed to have communication in some way. And initially, that was really easy because you just requested something from a microservice. If it needed something else, it would ask another microservice for that. And that could go on for a while. Eventually, you get the request back. And finally, we get a response. This is generally how people initially build microservices. And it's very, very easy, which is quite nice. But of course, it had some issues. This API communication had things that were very, very hard. Like, for instance, if you had 2 microservices that you would quite like to run in parallel, this was more complicated because generally speaking, those requests were single-threaded. And that was a bit of a problem then to split those. Well, splitting them was easy. Joining them was really hard. So deciding on when these 2 things are finished, we'll do the next thing. Updates and maintenance was really hard. If you look back at this, we have 3 services here. If we wanted to change this one here, we actually need to change all 3 because changing this one means this one now has to change the way it sends its request and also the way this one sends it or receives it. So that was a big issue. As well, if this goes down, this thing can't do a large portion of what it does. OK. Also, the black box mechanism. Once you made a call into your lovely microservices, it came back at some stage, but the process by which it would call different things, especially as your architecture grew and as you added more services, would often become far more complicated and be much, much harder to know exactly what's happening, in which order, and more importantly, when something breaks, exactly where it broke. OK, so where do orchestrators fit in? Well, our little bird now, instead of pointing at this, is going to point at this. So this component here is an orchestrator. It has essentially 2 jobs that are really important. The first is maintaining state. Okay, so it is a database of state, essentially. Database is where you keep your data and where that's the source of truth. This is the source of truth for state, which means that when we would ask this thing, please run my process, which is my series of tasks, and this is the thing that knows how to make those requests. The second thing it does is make decisions, because depending on the result of the microservice, you may need to do some other bits and pieces. And this service here shouldn't be the thing that's in charge of deciding what to do next. That's a very bad idea. Instead, it should say, here is the result of what you told me to do. I would like the orchestrator to please decide what happens next. Why? Because if we do that, we have this lovely component here, which is fully in charge of making all kinds of decisions about how the process should progress. And this never needs to change if other services do. OK, so that's how orchestrators tend to fit in there. These things can be lots of stuff. It can be a message bus in some cases. I'll be talking specifically about process orchestration and why it's important to use that particular kind of orchestration, or more importantly, why people like to use it. Parallel tasks are super easy. I must remind you that the thing that's complicated about parallel tasks, if it isn't already obvious, is not doing 2 things at the same time. It's doing 2 things, and when both are finished, we then want to continue. That's got that little bit of extra state management that's required, and we'll talk a little about that as well. Updates and maintenance is much easier, because if this is holding state, this thing here can make a call and request, and once that's finished, I can hold the state here until this comes back online, for instance. Okay? Or if there's an error thrown here, I can do a retry from this point here. So it's super handy to be able to deal with updates and maintenance. It also means that we have a certain point where changes are made specifically about state and decisions, another place where our business logic changes, and those are usually independent. And visualization and clarity are kind of key, and that's the kind of where you get the main sort of benefit from an orchestrator rather than a message bus, for instance, because you can really see what's happening. And I'll probably demonstrate that. So why do people use those things? Well, of course, I'm going to demo something, because why tell when I can show? So here's a very simple process. This, for those who don't know, is BPMN. Who already knows BPMN? Oh, my goodness, my people. So yeah, I often go places and no one's ever heard of it. They will lie and say they have, but they haven't. It's like a really, really indie movie or something. So this is BPMN, Business Process Model and Notation, and it is the way most orchestrators tend to keep state. The reason they do that is because it's a ISO standard, it's maintained by the object management group, and lots of engines and process orchestrators use this as a visual aid because it's executable. The thing you build actually runs. It's not a diagram in that case. So if we take a look at this is a very simple little process in which, I'll just do a simulation of it now, in which we have, let's put some wait states here, okay, where we start our process, we enter some details for an email, we trigger some old system in parallel, and then we send an email, for instance, with the contents of this lovely thing. Now, as you can see, we are waiting at a very given state. This thing here is kind of important. This is a parallel gateway that's waiting to merge. And this is what I was talking about earlier about how running things in parallel requires this particular thing, being able to have a place that can wait until, for instance, this thing finishes, and then be able to join those and then continue. Okay. Another nice thing that a process engine can do is deal with events that happen. Now, in this case, I have an error event, an error boundary event. And if this thing, for instance, not all services complete magically and everything's fine, some of them throw errors, which will be a surprise to most of you. And when they do, you need to deal with that in some way. And in this case, we can throw an error that can then be caught and move the state around. The state kind of continues. You don't need to deal with it. And then this process continues. Now, this particular event is linked to this task. But of course, the really nice thing about using a process is scoping. We actually have a concept that this process has a history, it has data, and it also has a scope. So if I zoom out a bit, I also have this thing here. So this is a event subprocess in the top there. I don't need to explain it because you people know what that is already, but for those who might want a refresher, this is waiting for a global event that could happen at any time in this process. And the event in particular is a timer event, okay, a non-interrupting one. Which means if this is taking too long, you don't need to do anything except for put this here, and this will then trigger a new instance. Someone will need to check the process and then continue it. So maybe the email sending is taking a while. This triggers. Then we go forward. OK. And they're happy. This continues, and everything's fine. OK, so that's a basic BPMN lesson, and that's why some of the core components of orchestrators are demonstrated really well with BPMN. OK, so let's just quickly run this so we actually can see what that might be like. I'm going to just start an instance. Great. Because we've done the first bit, which is just visualizing it. So let's take a look at where we're at. So this is then, if you were actually using this in production or for a real process, you would see something like this, which actually shows that the process is currently here, waiting for someone to enter some details. And I have a task here that has shown up, in which I'm going to send some information. Reb, the email is about, oh yes, I have his email address right here, because God forbid I would actually type something I could copy and paste. And I'm going to have this sport. And the email body is, are you looking forward to seeing Ireland beat South Africa on Saturday? Okay, what sport am I referring to? Any guesses? Cricket. Yeah, like we would ever beat South Africa at cricket. This is, in fact, rugby, a sport that I'm very glad the Dutch don't play, because you guys are big. So we have now completed our user task, which means the process, of course, has moved on. And actually, it's moved on quite quickly. So it's already gone through that whole system. And we can see that there's the details of Reb and stuff. And he probably got an email at some stage saying something inflammatory about his team. There we go. Oh, thanks, Niall, for that. So now another key, the last thing I want to demo before I go into more details about the integration, because I haven't talked about that as well, that's mostly about what this is going to be about, is versioning, which is really important. You may have noticed that I check for spam in the content of this email at the very end after it's been sent, right? Which is not very useful. So it's very often the case that you decide, I need to change the order in which these things happen. So we can do that really easily. I'm going to just create a milestone here, and I'm going to just change my process a bit. So I just need to move this here instead. Oops, let's get rid of that. And just reconnect the things. So now I will just run this thing first. OK. So I've now changed my process. I don't need to change anything else. I can just deploy this now to Unstable Unicorn. Great. Start a new instance. And there we go. So now we have the newest version is running. And the services themselves shouldn't be affected. That's a key component of the orchestrator. If we are solely responsible for state and state progression, it shouldn't matter how we're actually changing the order in which things run. So as long as we understand the end of it. So there we are. So this then can trigger this, do this, and then loop around. So that's just a quick little demo into that. I'll come back a little later. So now let's talk about integration. When I talk about integration, I'm talking about the little microservices that are represented by these boxes, and how people might want to trigger those. And the two ways people tend, or the two ways right now that orchestrators in general choose to go is a pro code sort of concept called pro code and a concept called low code. So they both come from different perspectives. The pro code, I have a clicker for this. Why am I using a keyboard like some sort of animal? So the pro code sort of scenario comes from a growth of microservices in particular, from like the idea is we have microservices, they're already in code, this is an additional part of our infrastructure, so it should be code too. Also, it's intended for software developers. That's very different as well. Pro code orchestrators tend to see developers as the main users for the orchestrator. And because of that, pro code orchestrators tend to focus a lot on flexibility. That could mean flexibility of the language you use for your services. It could mean flexibility in terms of how you scale it, or how you control it, or where you keep your source code. Low-code stuff came with the growth of citizen developers. Citizen developer is a weird term that basically means people who sort of have enough coding knowledge to be able to kind of put stuff together, probably understand expression languages quite well, and therefore have enough sort of ability to lock things together if they are sort of given a good sandbox to play in, where they can't break too much. It's intended, of course, for process owners, people who know the process but don't necessarily know the code that's running. Not necessarily the builders of the microservices, but rather the owners of the sequence of events that they expect to happen. And finally, it prioritizes simplicity. When I say simplicity, I mean that it wants to be easy to use. It wants to be a very, very simple experience and fun experience. So with pro code, the usual architecture works like this. You will create a process, which I mentioned before is independent of your services, and the vendor will be an engine, a process engine, will have that process, and you also create your services. And they're yours now, and they exist somewhere else. And then you basically connect up these little boxes to the specific services you want to run, okay? And so you basically own this section here, while this thing here is essentially maintained, the state and the state progression maintained by the engine itself. Okay, and let's show you how that works. So let's first of all show you some code, because that's important. This is a really simple little Spring Boot project. It's very basic. Anyone who's come by the Command booth earlier will know this is a game. This is part of a game I built called Who's 50. It queries an API for us with a celebrity's name, and then returns the age of that celebrity. If a celebrity is exactly 50 years old, you win a T-shirt, if we have any. So for those who might want a T-shirt, that's how you win. No Googling, that's cheating. So this is a very simple service. It's written in Java, and I would like this thing to be orchestrated by the engine, right? Now, the change to my service I need to make is not too much. In the POM file, I've added this dependency here, which I hope you can see. Actually, not really that important to see it, but this is just a helper to help you connect to the engine. So, and also the location and the security credentials for the engine. Please no one memorize this. This is a secret. Good. And then finally, we've connected to the engine, and we've also defined our our dependencies. So now we just need to say, this is the key line here. This basically says this type here is the name of the work I do. This is the correlation key between what the service is going to do and what the engine is going to require. Okay, so my service is now, I can just start this, it should be. So this is now up and running, I would hope, and it's going to be pointing at the engine, and it's waiting for work. We don't have a process yet, but that's what I'm going to build right now. So let's run into here, and let's create a new Beekman process, and this is going to be a service task. This is going to be who's 50, and it's going to have an XOR gateway with 2 exits. Are they 50? And this is a yes. You win. And this is a no. Now, I don't really mean, but let's go win less, just in case people feel a little bit funny about it. So this is my model. That's kind of, so now this is the pro code example, and as such, I need to know a lot about the service that I'm trying to orchestrate, okay? I'm expected in a pro code example to be able to access the source code, or at the very least, a lot of information about my service, because it's quite unique. So let's grab this thing here, and let's add this thing here. This is the most important part. This is the type I talked about. So that's this thing right here. This is the correlation between running which service gets run. The next thing you need to know is the variables that come back. So you can see here, I'm not going to spend too much time on this, but a variable called age comes back. And I also need to know how I can deal with that. So age needs to equal 50. And if not, we go this way. OK. So there we go. That's our process. Let's call it cool game, because I'm not in marketing, unfortunately. They should hire me, though. Cool game. Next one. And now I'll just deploy this. Great stuff. To unstable unicorn. Deploy, start. OK, let's do that. OK, so now I've started an instance of it, and it probably broke immediately, actually, because I was supposed to add some variables. So let's start a new version of that. So I need to start. I also need to know what variables are expected, and I can do that in here. And I can say, I think it's called celeb name. And any celebrities who are 50 years old, anybody? Sandra Bullock. That's good. I'm not sure how to spell her name. Ooh. Bullock? That doesn't sound good. OCK. Thank you. That's the kind of audience participation I like. OK, so let's send that in. And let's see what happens. That one's probably more interesting. So this one's going to start up, and we should then, the process should start. Is this thing even running? Oh, it is. And this actually has already finished, but for some reason it's sitting here. Oh, it's a real shame. We can look at the variables here, and we can see that her age is 58. Actually, wow, she is older than I would have thought. So there we go. There is a very simple way where a pro code developer would sort of deal with an orchestrator. And there's some key takeaways from this. The first is that, generally speaking, it's best used with highly specialized services, because this particular example is not something you're necessarily going to find everywhere. It's a microservice that does something very particular to what I want. In low-code scenarios, you'll see later on that usually very common things you'll find everywhere. You'll find a connector for it. You want maximum flexibility. I used my own IDE. I used the language I chose. I could have used NetBeans and Go, for instance, if NetBeans works with Go, I'm not sure. And easy error handling and debugging, because I can look at my stack trace very easily, and I can deal with it, and I can really fix it. And as a developer, you need to expect that. You also have the freedom of tech choice, which I mentioned, and also one of the things that's both a good thing and a bad thing is developer skills are required for this kind of approach because everything about the pro code approach is expecting this to be in front of developers. Also, you can adhere to the usual practices of CI and testing because you own the source code, you own the service, so you can do exactly what you normally do, which means it can integrate really well with your services. Also, it exists in your own developer's ecosystem. If you already have these things, it's great. A very important thing is actually kind of overlooked sometimes when it comes to trying implementing low-code stuff is it's very easy to integrate a microservice orchestrator that's pro code if you already have the services, because the flexibility that it's designed to offer will often work towards that. So let's talk about low code. What are the main differences? Architecturally, the fundamentally big difference is where your business logic is. Okay? Low code, first of all, you configure your process, that doesn't change, but it's almost never the case that you're hosting your services. In most cases, low-code vendors have connectors to very common services that are like connecting to, I don't know, Google Drive or Slack or whatever. You'll see a whole bunch of these connectors that are pre-built. And usually they're owned by or they're maintained and hosted by the vendor themselves. So let's quickly show how that might look. Okay, back to our model. Let's go here. I didn't even name the last diagram. So in this case, I don't need to know anything about the service. I haven't even shown you the service. Why not? Because I don't know what it does. It's going to send an email, because that's just the cool thing to do. So in this case, let's say email details. And that's just a user task. And then finally, I want to send an email. Now, previously, I selected a service task, which gave me all of these lovely things like inputs, headers. I had a template I could choose from. I have all this really fun stuff. And this is not good if you're a low-code developer because there's a lot going on there and you don't really know how to use it. So if I scroll down, we have a send grid connector. This is a classic low-code option. Now, the first thing that happens when you use a low-code thing is they strip away anything you don't need from the properties, almost always, even though there's a whole bunch of properties being set behind the scenes. And in this case, we have a send grid thing. Again, there it is. Let's grab that. So we need to add a secret. We need to add the name of the sender, which is Niall. Niall loves sending emails, so please don't send her spam. Receiver, let's send something to Reb again. And there we go. And as a subject, oops, there we go. Let's say, hi, Reb, and just say sorry, because I kind of feel bad. So there we go, let's send email. And we can start the process, great. And yeah, deploy it, start it. And we can then take a look at the task that we have, which is here, probably. Did I do that? Complete? Sorry, I'm a little bit clicking around because I don't want to run out of time. Let's take a look at my processes. Wait, did I deploy that? Oh, you're a star. Thanks for noticing that. This is why ooh, an error. Cool. See, errors are great. Sorry, I slightly distracted there. Let's return to my model, and let's deploy this to the correct cluster. Marvelous. Thank you for that, by the way. And let's start the instance. Now I can actually go somewhere like here and see it. Great stuff. And I'll just, to be pedantic, I won't use the user interface. I will just move this myself to here. Great. So as a fun little admin tool. So this then will move it. Now the important things that I hopefully demonstrated just now are that this didn't really require any knowledge of the service I was calling. I understood it. I had a nice template that I could use, and it was implemented, and the email got sent, and Reb should have something else. A little apology email. No problem, Reb. You're great. OK, that's that done. So let's talk a little bit about low code now. So low code, very easy to reuse services. Loads of processes that people build reuse very common services, like emails, like Slack integration, like Lambda functions, for instance. But they have the same boilerplate code, and it's really easy to reuse these services with these. Enable citizen developers. If you don't already have citizen developers, but you want to start like creating this department like that, low-code approach is really, really great because they don't necessarily need too much to get started. No boilerplate code needed. Speedy development. You saw how quickly I built that. I needed to talk to nobody. I clicked a bunch of buttons and deployed. Almost all low-code vendors have a very similar thing. They want this to be done very quickly, and they pride themselves in that sort of ability. They usually have a purpose-built developing tool. For better or worse, the majority of low-code stuff, like if anyone's used UiPath or something, or some kind of RPA tool, you generally are given the tools you need to use, and they're the ones that you have to use. That can either be good or bad. Sometimes it's a little bit weird, but you know. So you can automate things very quickly with relatively low investment, which is really nice. So things that you really that would take quite a lot of development time, that are pretty simple processes, can end up being automated quite quickly with low code. But of course, there are some bad signs as well. There are some pitfalls to low code and some things that we've seen when people are building them. The first thing is low code stuff is very hard to test. The key thing about low code is as well that it tends to be low stakes. Not a lot of people use a low code thing for something that is a core part of their business. Again, it's because it's quite easy to put together, but that means that you can't just write a unit test for a low code platform. You normally just test it yourself. You also don't own the code, own the services code themselves, so it's hard to know exactly what that's doing behind the scenes. Error handling is complicated. Because the vendor kind of controls that ecosystem, they own the state and the process, but they also own the business logic and the connectors. Where the error is happening usually takes some time to figure out. And in some cases, you won't even be able to fix it because maybe you don't own the section that's breaking or something. The ownership of business logic is an interesting one because there's a safety in being able to design, build, and maintain your own business logic. And giving that up to a vendor kind of leaves you a little bit open to, like, you no longer own this thing that you've built. It's kind of locked into them. And part of that is reliance on third-party connectors. Most low-code vendors will build a whole bunch of connectors, and they're usually really useful. But if they don't have the one you want, maybe raise a feature request or something, but you are limited to the numbers that they have. And if they work or not, or if they're good at what they do. High complexity becomes very difficult. As soon as you need to do things that's quite complicated, when I say complicated, I mean like, parsing a complicated object that comes back from a REST call or something. Like, that can be quite limiting. You can find yourself kind of like, I'm not sure exactly how, if I could put a script in here, I would know how to do it. But generally speaking, this is a sticky thing. The proprietary tooling can be a massive pain because you might have to license it, and also you're stuck with it. If it's bad, then that's the end of that. The key thing that people come back to, and I left this at the end because it's kind of a longer thing, but low-code platforms are very susceptible to vendor lock-in. They own every part of what you build. In the sense that if you try to migrate, they're not really interested in that at all. So I'll give you an example. There's two. So BPMN, the notation that we just saw, is an open standard that anyone can use, and loads of vendors use BPMN as a way of describing state. And actually, loads of vendors allow you to upload BPMN models from other tools, because that makes sense, because they all write the same standard. And then there's a whole chunk of them that don't let you export them, right? Which is great. So they'll let you import into their system, but they have no interest at all. There's even one tool, I can't remember the name of it, that you have to pay an additional subscription fee for the feature to export your BPMN, which I think is really nice. It's a very good system. But so low-code platforms, because they have such control over the tooling you're using, where you're keeping your state, and your business logic, they really do kind of own that process. And it's not that it's impossible to migrate away, but it becomes very, very hard. Okay, pro code isn't great either. Well, it depends who you are. But you are responsible for your services for better or for worse. So in some cases, people quite like the idea that I don't have to deal with having to create a worker that sends something to Slack. you also need to write all the code, even if it's very basic. So a pro-code approach expects developers to be able to build most things themselves, even if that means copying and pasting from Stack Overflow. You still have to find that Stack Overflow thing from 11 years ago and scroll down to the second comment where the actual answer is, and then copy and paste it. That just still has to happen. So it's a little bit of work. It does require skilled developers because they need to be able to read the code, and also they're expected to deal with the errors and fix them, that sort of thing. Development can take much longer. This is down to simply integrating with the testing frameworks we're all used to from developing. And CI/CD, things that low-code platforms don't usually bother with, are all part of the development cycle. And therefore, it will take longer to do these things. Fewer pre-built services is another problem. Kind of relates to you have to write all your own code. But it's kind of an antithesis to the low-code approach where you can often just find someone who's built something in low-code. So, which one do you use, generally? Well, with pro-code, generally speaking, you would want complex services. If something is complex, and the services in particular are complex, pro-code is a very, very good place to start. Critical business processes are also really, really, I would never put those near a low-code thing, because you should own your complex business processes, the ones that are core to the selling point of your company, but also because chances are your critical business processes do something that's quite unique to your company, right? That actually has a particular, there's no connector for that, or the low-code approach is not going to give you the flexibility to make you better than your competitor, for instance, if you do the same thing as someone else. Your business processes are the things that can make you stand out more. Also, we have, if you have an engineering-led project. Now, generally speaking, a project consists of someone who designs the process or someone who knows the process, and then they describe it and build it. And that's all fine, but then if the core of the project is being led by engineers and being developers, so like for instance, you usually, here's the process I've designed, and you hand it over to the engineers to actually go and make that executable and build it. Pro-code makes a lot of sense because, as I showed earlier, pro-code is designed to have users understand the services they're orchestrating and the process. Low-code, you don't usually, you shouldn't need to understand the service in too much detail. If you have existing systems, existing services that you actually want to use an orchestrator for, clearly pro-code's where it's at because you can still keep using those. In some cases, you might have an existing system where you've built a bunch of very common services, like as I mentioned, maybe something that sends an email or something that connects to Google Drive or whatever it does, or maybe even Kafka, for instance, something more likely. It might even be a little bit easier then to replace those with low-code approaches, but generally speaking, only if you've written some really, really bad code would you want to do that. Also, another very important one is developer resources. One of the big benefits of low-code is that you really don't often need skilled developers to build these things because it's not really a requirement. A skilled developer could do it, that's no problem, but it's not really a requirement. And if you have the developer resources, you probably should opt for pro-code in general. Probably a good idea. Also, for low code, so if you have a greenfield project that doesn't have any legacy stuff to deal with, it's a nice idea to start looking in this direction. The reason is because you then don't need to be doing reintegrations. You can start from the very beginning. It's much easier. If you are doing a very common business process, a very common business process might be something like basic onboarding, for instance. Let's imagine that you need to set up a Slack account and also order a laptop or something. These are things that are internal, or we'll talk about it later, but they're very, very common. These are things that are not, if they break down, are not going to cost you a huge amount of money because the service that you sell is actually not working. These kind of common business processes, it's a really good idea to try. I mentioned earlier, it's mainly because the effort it is to automate these things is usually worth it. Within your company, these very simple manual tasks can be really easily automated, even with low-code stuff in most cases. That goes with internal operations, I guess, in the last point. If you're doing loads of things internally, we do this ourselves, actually. in Camunda, we have our lovely little process engine, and we have a whole bunch of internally orchestrated services that do all sorts of stuff. Up until, like, I think we built them recently, some low-code stuff, but all like that. For instance, when people enter some information in the contact form, it goes somewhere and does some stuff and triggers different platforms. But also some quite complex stuff that's internal as well. For instance, if we want to check that a potential customer is on like some sort of a blacklist somewhere in some jurisdiction, we've automated that process as well, because it has to check loads of different places and the different individuals associated. It's actually quite complicated. And we built that internally, and that works really well. Low-code is also a no-brainer if you already have a really strong citizen developer team. If you already have sort of a team that is very happy to automate stuff, then that's a really good idea to try and bring these projects and use low-code to bring those. OK. And the final thing is the hybrid model, a weird combination of both. It doesn't really exist too often, but it's really, really possible. And so I'm going to quickly show you how the hybrid might work by spinning back over here to our code. So if we look at our lovely worker here, you can see Sandra Bullock is still 58. It's been minutes. And I would like, for instance, this lovely service to be usable by someone who doesn't need to look at it. That's my goal, okay? Because what I want to have in a hybrid model is the benefit of being able to use my own code, to be able to host it, do what I want, but they use all the same tools I'm used to, but also give access to a citizen developer if they want to use it, right? So for that, you can basically build that, because you already have the service, and we know a lot about it. So if I go to here, let's see, I'll show you. There we go. OK, so this is a little bit of JSON that is describing how I want this panel to look on the right. Okay, so the first thing that's quite important is you remember when I first built this, I added the check celeb age was by far the most important thing because that correlates the work with the model. So I am adding that, but I'm making sure it's hidden because I don't need a user to even look at it or care about it or, God forbid, edit it. So this needs to be added and hidden. So you can first of all start adding sort of some hidden configurations that don't confuse the user. The second thing is that we need to describe what's needed from the user. And here we have the celebrity name. And if we see here, we have a label, celebrity name, the description, the type, feel. Who knows feel? It's the friendly enough expression language. It's adorable. It's also by the OMG. Those who load DMN might know that as well. So the binding is here, which is basically telling us, it's over there, yeah. It's telling us exactly what kind of field this is. This is an input field. This is a variable that we're expecting to be input here. And then finally, we have the output field here, where we expect this is the output of our system. All this information, if you were a developer, is readily available. You can look into it and see it. But of course, in this case, we know that the person who was going to be using the service is not going to have that kind of access. So, and I think then, if I go here, where's this thing? Yeah, this is fine. So there's who's 50 again. So let's get rid of it, and let's just drop this one here. And we can see if we go here, we can scroll down to who's 50. And we can see that we have this lovely, cool little icon of a crocodile with little horns, and which, of course, straight away will let you know this is an age-orientated thing. And we have the ability, we need a celebrity name, and this can be, I added field because one of the things that's important is being able to, one of the things that's even citizen developers need to actually learn and understand is expression languages for almost all kinds of low-code platforms. They usually there's most of them have some kind of proprietary one, but they usually follow the same rules. So here I'm basically saying a variable called name will exist, and that variable then will be put in here. And then, of course, celebrity age is just going to be age. So this is the variable name that we're giving to the output. So the output will be mapped to a variable called age. Alrighty. And then I should be able to deploy that. She's unstable unicorn, great. And start it. Okay. We'll also see the versioning and stuff, which is quite nice. So we'll be able to see if it loads. I should think of a song I can hum that takes exactly as long as it takes to load a page. There we go. Through an error, brilliant. Okay, so I did want to talk about error handling, so it's actually quite handy. So this, as I said, is a hybrid approach, right? So we are expecting, this is an admin tool, and we say we have an error right here, and we can see the incident. And the incident says, exciting, failed to validate expression celeb name celeb. Okay, so what happened there? I didn't, it told me it was expecting a variable called name that I was going to put in there, but I didn't add any variable called name. Okay, so that's why it's throwing an error. The nice thing is that the error really happened, of course, here, somewhere, potentially. It should be throwing an error somewhere. Well, it happened in this service, and it's nicely enough here. Actually, this didn't actually. This happened in the engine. So what can I do about this? First thing, I need a variable, so let's add one. So let's add name. Anyone know a name of someone I can spell? It's Ben Affleck. Oh, L-E-C-K? Affleck? Okay, cool, that looks good. Double F? Great. I love this debugging you're helping me with on celebrity names. So let's add this, and now, of course, we'll just rerun this, so retry it. Let's see what Ben Affleck is. So this basically, a nice thing about an orchestrator, of course, is the state handling. So when any service errors, it throws back to a centralized point where you can deal with it. Someone cheated. I mean, well done. That's a wonderful guess. Yeah, maybe I'll give you a T-shirt one day. So Ben Affleck is indeed 50. So well done, you. Okay. So that brings us to how do we use either or? So we have pro code, low code. We're now adding this hybrid model. Personally, I've only ever seen the hybrid model actually work in very large organizations, and especially large organizations that want to separate concerns. They want teams that are building services depending on their banded context or their domain. So a certain team, let's say, are in charge of accounts, so they'll build the microservices that do things like open accounts, close accounts. Maybe they do any sort of things like getting information around those things. And they will just build those services, and then another team that needs them will build the processes and the models. So in very large companies, this works really well to scale if you're using a lot of processes. And if you have multiple departments that all need to build processes and services, this makes things go quite quickly. Because because the alternative is that the departments that want the processes have to directly communicate with the developers who need to build them. And that can take a lot longer. And also, it can do a lot of duplication as well. You could have departments building multiple of the same services. But if you have this nice thing saying, here's a template and a service, we have it hosted, it's really, really easy to build that. Also, I say here, large number of processes. This is obviously this upfront investment of creating a team to build services and another team that builds processes really does require you to be expecting to build quite a few processes. You can't just decide to start this off for small projects. You have to be really invested in the process automation stuff. And then also, large number of citizen developers, good idea, and software developers. A nice combo of both is really, really handy here, because there's no point in building this if you don't already have citizen developers who actually expect to build these processes. What might end up happening is, if you don't, is the developers build the services, but then they're also required to then build the processes as well, and you kind of get lost then in the mire of that. Okay, so these are the three main ways I think we've seen around integrating services in orchestrators. And I think that's all I have to say on the matter. Let's find out. Last slide, maybe. Hey, there we go. So thanks very much for listening. I hope that was useful. I'm here to answer any questions, if you have any, right now. So let's do that, just in case. Do we have a hand anywhere? Because I know people may be scared to speak. That's okay. I'm very intimidating. It was the rugby thing earlier, wasn't it? OK, well, in that case, I shall let you go. I'll be right here, so if you want to come down and whisper your question to me, I'll also accept that. And thank you very much.